My name is Mex Danny Hawk, pronouns they, them. I am a math specialist at the Learning Commons, and today I'm going to take you guys through test review 1. If you have any questions, I do have the chat box up on a separate screen, so I will be periodically looking at them. And of course, if you have a question, please feel free to chime in throughout this review at any time. For those that are walking in, please just put your full name in the chat for attendance purposes, especially if your Zoom name is not your full name. And let's go ahead and kick this off. So can you guys see the screen all right? You guys can see it says test review 1, and there's a question on there. And feel free to unmute. Oh, I got one thumbs up. Thank you. I appreciate that. Couple thumbs up. Awesome. Okay. So let me bust out annotate here. So if we're looking at this first equation, it wants us to simplify the following expression completely. So we have x to the 17th times x to the 5th. What do we do here?
If you have the same denominator, can't you just add the exponents?
Yeah. If you have the same base and you're multiplying, you add the exponents. So this becomes x to the 17 plus 5 or x to the 22. Okay. And that's just the rule for that. So be on the lookout. It's going to be really important to know your exponent rules for this test. And again, lots of people popping in. If you're just coming in, drop your name in chat. Okay. Any questions about this one? All right, let's go ahead and move on. Okay, so this one wants us to solve for x. What do you think is the first step we're going to do here?
Get rid of the fraction.
Yeah, the biggest issue that we have with this one is that we're solving for x, but we have x in the denominator. So we're going to need to multiply that denominator on both sides. Okay. So if we rewrite this, we have y times 6x minus 7 equals 7x minus 4, as anything over itself is equal to 1, so those are able to cancel out. Yeah, if you want to follow along, you might have different numbers, but you might be able to find this review on Canvas. Okay, what would the next step be?
Distribute the y into 6x minus 7.
You got it. Yeah, we got to distribute that y. So this becomes 6xy minus 7y equals 7x minus 4. Now remember, we're solving for x, so it's really important for us to get x all on one side. So we're going to move one of these x's over. Let's go ahead and do 7x. So we'll move 7x. Okay. That cancels that out. And now we have 6xy minus 7x minus 7y equals negative 4. What's our next step here?
Move the y's.
Yeah, let's get the y's all on the other side, right? So let's add 7y to both sides. And now we have 6xy minus 7x equals 7y minus 4. So we're solving for x. This is where we tend to make the most mistakes. What should we do here?
Factor out the x on the 6xy minus 7x.
You got it. Yeah, this is where you factor out the x. So we're essentially doing the opposite of distribution. And we'll be left with 6y minus 7 equals 7y minus 4. And then, of course, that last step, we got to get x by itself. So we're just going to divide, since this is multiplied, by 6y minus 7. That cancels. And we're left with x equals 7y minus 4 over 6y minus 7. Any questions about this particular problem? Okay, because one of these is definitely guaranteed on the test. So just remember when you get to this step right here, to factor out the variable that you're solving for. Okay, let's go to the next one. This is dealing with finding the domain and range of a graph. And it wants us to do it in interval notation and set builder notation. The questions on test 1 is dependent on your professor, but that's a great question. It could be anywhere from, I mean, it just really depends on the professor. So, but if you do have if you have a test review in your Canvas shell, I encourage you to check it out. And if you're in any of Julie Hannibal's classes, you have this particular test review in your Canvas shell, you can follow along with me. So what would you say?
I'm sorry. You were talking. Go ahead.
Oh no, what was your question?
You said that this test review is available in a Canvas shell. Where? It's available where?
It depends on your professor. If your professor is Miss Hannawell, it's going to be, it should be in your Canvas shell under modules.
Okay, no. Okay, thank you.
No problem.
Are all of our test reviews the same?
Yeah, so everyone's going to be tested on the same stuff.
No, but I'm saying, like, you said pull up your test reviews.
So it might have different numbers. That's what I'm saying. You can follow along and see an example, or you can just follow along with what I'm doing and write down what I'm doing. Yeah.
Okay.
So what would be the domain of this particular function? And this is a reminder that the domain is the range of x values.
-3
minus
1.
2.
Yeah, if we're looking at the range of x values, it's -3 to 1, right? So if we're writing that in interval notation, we're going to start at -3 and end at 1. Now it includes -3, so we use brackets. Does it include 1?
No.
Nope, so we're using parentheses. How would we write that in set builder notation?
It'll be -3 is less than or equal to x, and x is less than 1.
You got it. Good job. All right, now we're looking at range, which is, of course, the range of y values. So what is the range of this function?
Is it -5 and 4?
Yeah, if you look at the graph, it starts here at -5 and it goes to 4. So -5 to 4. And the in interval notation, does it include the -5?
Yeah.
Yep. Does it include the 4?
No.
Okay, let's take a look and let me go ahead and erase that. So is this right here a point on the graph?
Yeah.
So since it's actually a point on the graph, it does include it. So even if it doesn't, even though it comes down and stops here, because it goes through this point and touches the -4, it is included. And so we use a bracket for that. And someone give me the set builder notation for it.
-5 is less than or equal to y is less than 4.
Close. Remember,
Less
it
than
also
equal to.
yeah, it also includes that 4. So you got to add that the less than or equal to sign. But great job, and great job remembering the y.
Sorry, I thought you were done talking. How do you know which sign to use?
Oh, for these right here.
Yeah.
Great question. Okay, so these are the signs that you usually see, right? And then you might see that one, right? So this one is less than or equal. Just remember that we read everything from left to right. So whatever this is, in this case, x would be less than or equal to whatever's on the right side. If it's here, it's going to be greater than or equal.
No, I know that, but like, how do you know like when, like you said you did, for example, you changed the sign for the first one and the second one on like the second part, but like we don't know what y is. So how do you know that like it is greater or it's not greater than?
Well,
I mean, I'm explaining it right.
we talked about the range, right? We said that the range of this graph, because it starts from -5, it goes to 4, right? So we know the two numbers that this range is between. We also know that since this is closed, it includes -5. That's part of the range. So we know that that's equal to. And because this is a point at 0, -4, that 4 is also included. Therefore, it is also an equal. If we looked at the domain, right, we notice that the domain, if we look at the graph, starts from -3 and ends at 1. Again, this is a closed circle, so it includes that point. So we have the equal sign there. But this is an open circle, which means it leads all the way up to 1, but it does not include it. So we do not have that equal sign.
Oh, okay, got it. Thank you.
No problem. Any other questions on this one? That was a great question.
Yes, I got a question. So I see you closed it. You put -5 because the circle is closed and you put the underline under it. But the second circle isn't closed. So I was seeing, why did you still put the underline under it?
You're talking about for this one?
Yes, yes, yes.
Okay. So remember, we said that the range here starts at 5 and it
Right.
goes to 4, right?
Mhm.
Remember, this is going through 4. This is a point.
Oh, okay.
Yeah, so it still touches it. So remember that your range and your domain might not necessarily be the literal start and end of the graph, right?
Mhm.
Because it ends here, but it doesn't, the range isn't to 3. It goes as high up as 4.
Okay.
So just be careful about that. And just remember that if it's an actual point along the line, then it counts.
Okay.
So if it's an actual point on the line, there is a line under the sign, but if it's not an actual point, it's not equal to, it's just greater or less than.
Correct. Yeah. So this one right here, this point right here, that 1, 3, because it's open circle, It's not an actual point. It leads all the way up to it, but it doesn't quite hit it. So just greater than or less than. Okay, I'm gonna go ahead and move on. Don't worry, that's not the last domain question that we come across. So here we're gonna solve this equation and give the answer as an integer or reduced fraction. I'm just gonna go ahead and write it over here. 3x plus 7 equals negative 6x minus 1. So what would be our first step here?
Distribute the negative.
Yeah, absolutely. Let's go ahead and distribute that negative. We'll treat it like a -1. Okay, and just bring everything else down. So this becomes negative 3x, and negative and a positive is a -7 equals negative 6x minus 1. What can we do from here? And just remember, you know, there's a couple routes you can take. We know that we've got to get x by itself because we're solving for x, right?
So
So
we're putting X on, all the X's on one side?
you got it, and all the numbers on the other.
Correct.
So we can start by combining these. What's 8 minus 7?
1.
Yeah, it's just 1. So we end up with negative 3x plus 1 equals negative 6x minus 1. And then as you said, we're going to move everything over on all the x's on one side and all the numbers on the other side. So we're going to add 6x. And I'll do this one in a different number. We will subtract 1. That will cancel that out and cancel that out. What is negative 3 plus 6?
3x.
You got it. And negative 1 minus 1?
-2.
-2.
And then
how
of course,
come,
yeah.
How come it's a pot, like after you subtracted the 8 and the 7, how come it's like a plus sign now, not a minus?
So this is a positive 8, right?
Yeah.
That negative is attached to that 7.
Okay.
So you're thinking of it as 8 minus 7.
Yeah.
And what is that?
1.
1.
So, okay.
So yeah, so it's a positive 1.
All right, thank you.
No problem. And then our final thing, that 3 is multiplied by x. So we got to divide by it to move it to the other side. And we have x equals negative 2/3. Just remember, if you're using a calculator for this one wants your answer as an integer or reduced fraction. So keep it in fraction form, okay? Any other questions about this particular problem? Okay, moving right along. I mentioned that we had more domain questions, right? So here's one of them. And they want the domain in interval notation. What's important to remember about radicals, or in this case, square roots?
You can't have a negative sign underneath the radical.
Absolutely. You can't have the number be a negative, right? Otherwise, we get into imaginary numbers. So since this, our x minus 11, has to be greater than or equal to 0, that's what we do. We set it as greater than, or actually, what we do is we set it as it cannot equal 0, right? But we're not done here. We have to actually solve for what would make x 0. And what would make x 0 here?
A positive 11.
Yeah, So x cannot be 11. How do we write that in interval notation?
How come the x can't be 11 if that equals 0?
Well, oh, you're right. It has to be greater than, right? Thanks for the catch. I was right originally when I was first writing it. So it has to be greater than or equal. So it has to be greater than or equal to 11. So how do we write that? Thank you for that catch. Please, if I make more mistakes or you see mistakes, call me out on them. And to give you an idea, if we have the number line here, and we have the 11, okay, can it be 11?
No.
No.
Okay, so if it's greater than or equal, can it be 11?
Yes.
Yeah,
Yes.
yeah, because remember, it just cannot be a negative number. And then it's greater, so it goes this way, right?
Infinity.
Yeah, to infinity. So how do we write that in interval notation?
11 comma infinity and 11's included.
You got it. And then just remember, whenever you're dealing with infinity, that's always in parentheses, because otherwise we're putting a number cap on infinity, and that's just not possible. Any other questions on this one?
What was the first step to this problem to answer it?
Yeah. So the key to this one, and I'll actually put it in a different color, is that the square root cannot be negative. So whatever's underneath the square root has to be greater than or equal to 0. So you set what's underneath the square root greater than or equal to 0 and solve.
And why is there a bracket for 11 instead of parentheses?
Well, let's actually plug that in, okay? So if we had 11 as our x, that would be 11 minus 11, right? Which is the square root of 0. Is that possible?
No.
No? What is the square root of 0?
Yeah.
Yeah, it's just 0. So because it's possible, it's included. Does that make sense?
Sort of, yeah.
Remember, 0 is not a negative number, so it's something that works. The only rule about a square root is that it can't be negative.
Oh, so we put the bracket there because we changed it from a negative to a positive?
Right.
Okay, perfect.
Yeah.
Thank you.
Yeah, it's just a matter of because 11 is included and works for this domain, it is included. So it's a bracket.
I just don't get why you do that at like x minus 11 is greater than or less than 0 or equal to 0.
Greater than or equal. So remember what's underneath. So we have the square root of x minus 11, right? This right here cannot be a negative number. So it can only be a number 0 or greater. Whatever's underneath the square root. Yeah, I'll do a similar problem. In fact, let me go ahead and find one because I know there is one. Oh, that's solutions, but let's go ahead and do the domain for this one. Okay, so we have y equals the square root of 7 minus x, and I want to know the domain of this function. Again, a square root cannot be negative. What it can be is 0 or any positive number. So what's our first step?
Just bring a 0 down there.
Well, remember, this is one of those where there's a restriction, right? Because it cannot be a negative number and it can only be something 0 or greater. So because that's the case, we're going to set what's inside the square root greater than or equal to 0. Because anything else would not work.
But what if you have like a negative number?
What happens if you have a negative number? What is the square root of a negative number?
0, I'm guessing.
No, but that's okay. That's a pretty fair guess. The square root of a negative number is an imaginary number. So it doesn't exist. If you, and I'll actually pull up the graph of it. Let me see, can you guys see this? See Desmos?
Yeah.
Yeah.
So if I were to put in, and I don't know, well, actually it'll tell you what's going on here. If I were to put in the square root of -1, notice it says that it's undefined. But if I were to put in the square root of, say, x, and just look at that, where does it start?
Zero.
It started at the origin.
Yeah, it starts at the origin. It starts at 0, and where does it go off?
Infinity.
Infinity.
It goes off to infinity, and it's all positive numbers. Okay. So this particular graph is never going to be a negative number. Otherwise, it's undefined.
Hold on, bro. Something don't look right.
Which one?
So it doesn't go the other way?
Not
Yeah,
for
like
square
it don't
roots.
go the other way.
Not for square roots. Mm-mm. Because remember, it cannot be a negative number. That makes it undefined. Just remember, the square root of -1 is I, or your imaginary number. So if you had a negative under the square root, it wouldn't be real.
Yeah, but on my review, I got like -20 minus x, and I put d and e, and then it says it's wrong.
Well, because you got to solve for it. Yeah, we're not done here. When you have let me pull up the thing again. So if we have, you said yours was what? The square root of what?
-20 minus x.
-20 minus x. So remember, the rule is this whole thing has to be greater than or equal to 0. So you set what's inside there greater than or equal to 0 and solve for x.
So just move the 20 to the other side.
Mhm.
And then, but would that still be -20 because the x is negative
Okay,
right now?
you'd have to switch it, right? So if you did that, you'd have -x is greater than or equal to 20. And then multiply by a -1. Gives you x. Don't forget to flip the sign if you multiply by a negative. So you have x is less than or equal to -20. So what's that look like on a number line? Or rather, interval notation? Where did the x value start?
Not sure.
All right, that's where you bust out a number line. Okay, so we'll say that this is -20. Since it's also equal to it, it includes it, right? If it's less than -20 as well, which way does it go, left or right on the number line?
All right.
Right.
Okay, so let's see. Remember on a number line, if we were to go here, that's -19, -18, -17, and it keeps going. Here,
So it's going to stop at 0, right?
well, what's less than -20? -21 or -19?
Yeah, I would
21,
say
negative
negative
19.
21 is more than negative 20.
Um,
Is it? Is it better to be negative $20 or negative $21?
Like negative 20.
It's better to be negative 20 because that's less. So, I mean, it's less that you owe, which means that this is a smaller number. So remember, you go to the left, you're going towards negative infinity. Think of it just like the oh, that's right. They don't have that. So if you're looking at this graph, right? These are our negative numbers, yes? -1, -2, -3, 1, 2, 3. So if you go to the left, you're going towards negative infinity. If you go towards the right, you're going towards positive infinity.
So when you initially pull the negative out of the radical, is it always greater than or equal to 0? Or is there any circumstance that would make it less than or equal to 0?
No, if we're dealing with a square root, we know that whatever we're pulling out, that whole thing has to be greater than or equal to 0. The only time it's going to be a difference is if it's in the denominator of a fraction. And that would be like if we had, say, let's do like 3 over the square root of x plus 5. The radical restriction whatever's underneath the square root is greater than or equal to 0, right? But what's the rule about a denominator?
Can't be 0.
Yeah, so the denominator of a fraction cannot be 0. So that's the only thing that would restrict it further, because then whatever's under this radical can only be greater than 0.
But for this problem, it's not asking for a domain. So
No. I just said we would look for the domain of this one.
uh,
Yeah, because someone wanted another example. Yeah, no, this particular question is something else, but it was a similar equation. So I said, let's find the domain. But if we were dealing, so back it up, if we were dealing with this -20 minus x, square root of it, and we found that x is less than or equal to -20, we're going to go to the left because those numbers are less than -20. So where does our interval notation start?
Negative infinity.
Yeah, you got it. Starts at negative infinity. And where does it end?
Negative 20.
-20. And again, it includes that -20, so brackets. Okay. Any questions? Any more questions on domain?
Do you set it to like to equals, not to equal, my bad, to be greater or equal to 0, even if the inside of the square root is like positive?
You mean like the x plus 5?
Yeah, like let's say it was like y equals x plus 5, the square root of x plus 5. Would you still do it like x plus 5 greater or equal to 0, or would you just do something else?
No, you still would, because you don't want to put a number in there that would cause that to be a negative number. So if you had the square root of x plus 5, I mean, say I said throw -6 in there, what's going to happen? If you put -6 in for x.
It becomes a negative.
It becomes a negative and we don't want that, right? But if I say something like, let's say that x is equal to -5. If x is -5, does that still work?
Yeah.
Yeah. So it's really important to, in this case, what we're doing is we're defining what our domain is, because we don't have the visual, so we can't just look at the graph. It's a matter of saying, okay, it starts at this value and goes to infinity, or maybe it starts at -infinity and it stops at this value. And all of these numbers are possible, and that's it. In this case, x plus 5 greater than or equal to 0. We'd move that 5 over, right? So x is greater than or equal to -5.
So if
Which-
we wanted to put that in interval notation, what would we, like, how would we say that?
Yeah, so that's a great question. So starting at -5, it includes it, right?
Yeah.
If it's numbers greater than -5, do we go left or right?
What?
Okay, thinking about a regular graph here.
Right.
Yeah, we want to go right. Because those are going to be numbers that are greater than -5. So what's our interval notation then?
-5 to infinity, -5 is included.
Yeah. Does that help?
For this actual problem, like the original one, do you just plug in like 2 points and see what you get?
Actually, you could choose any number for it. In fact, let's go ahead and do that next. If we were, and the equation could be different. We'll do with this one. When it says something like gives 2 solutions to an equation, and it wants ordered pairs, you are going to pick any number you want for your x or your y value and solve. I personally like to choose 0 just because it's a little friendly. Like if you chose x equals 0, okay. So then you have y equals the square root of 7 minus 0. And what's that? What's y equal then?
Square root of 7.
Yeah, just equals the square root of 7. And the coordinate for that, right? Because we're dealing with xy, is 0 square root of 7. Okay. And again, you could plug in.
What?
Remember, this is giving 2 solutions to an equation. So you choose a number for one of the variables and solve. And all you're doing is finding the other part
So you leave it as
as a radical. Yeah. And the only reason why is because it says using exact values, integers or radical coordinates. So we're not going to change, we're not going to actually put in a decimal value for the square root of 7. We leave it as the square root of 7. Yep. You could also put in 1 for x, right? And if we do that, we're just doing the same thing. Plugging 1 in for x. What's y equal here?
Square root of 6.
Square root of 6. Can that be reduced in any way?
Two and then square root of 3.
So really not, right? Because 2 times 3 is 6, but there's nothing we can pull out. So again, this one, our x value is 1. Our y value is square root of 6. The only thing you have to be careful about is picking a number that's not in the domain. But with these, usually if you choose something like, x is 0 and 1 or something like that, it's Shouldn't be an issue. Any other questions on this one? Okay. We go ahead and looking back real quick. Let's do this one. So we're given a function and you have to evaluate the following. So h of 2x, h of x minus 4, and h of 5x plus 1. So if I'm plugging in something else for my x, I like to put what would be my x in parentheses so I know what to plug in. Since we're doing 2x, everywhere you see a parenthesis, we put a 2x. Now what? Are we done? Or can this be simplified?
It can be simplified.
Absolutely. This 2 has to distribute to both, right? So that becomes 2 to the second power, x to the second power. And what about this 4? What can we do with that 4?
Times it by 2x to make it 8x.
Yeah, 8x, and then that minus 3 drops down. And what is 2 to the second power?
Oh.
Yep. So you end up with 4x squared plus 8x minus 3. And that, you're done there. If you do anything else, you're factoring, and this is just a matter of making it a simplified expression. Any questions on this first one? Okay. Let's take a look at D right here. Okay, so again, anything I'm going to put in parentheses is going to be the x values, right? So the x squared plus 4x minus 3. What we're plugging in is x minus 4. So everywhere there's a parenthesis, x minus 4. How do we start by simplifying this one?
Factor the x minus 4.
Yeah, what's really important about this one, right, is that we're not distributing like this. This is the same thing as saying x minus 4 times itself 2 times. So we've got to FOIL that through. Be very careful on that, because that's definitely the type of question you see on the test, where you have to FOIL through that first part. So what's this become? X times x is?
X squared,
X times negative 4?
negative 4x.
Negative 4 times x?
Negative 4x.
And negative 4 times negative 4?
16.
Yeah. Combine like terms. What's negative 4 plus negative 4?
Negative 8x.
We're going to bring everything else down, but we can also distribute this 4, right? So we have plus 4x minus 16 minus 3. And we can clean up. Negative 8x and plus 4x go together. And then we have 16 minus 16 minus 3. So x squared, what's negative 8 plus 4?
-4.
Yeah, negative 4x. And then what's 16 minus 16
0.
minus 3, right? Yeah, we can just cancel those out if we see something like that. We're not always as lucky, but you know, we were this time. And so that becomes our answer, x squared minus 4x minus 3. Remember, if you're just coming in, to put your full name in the chat for attendance purposes. Okay, any questions about this one? E is going to be just like this one is.
Could you do one that like shows a graph and then you have to answer like 8 different questions for the graph?
Absolutely. Yep. I think that one, did that one get skipped? Yeah, nope, not that one. Where's the one I'm looking for? There's a good one. Here we go. Yeah, this kind of question is definitely on your test. You're given a graph and we're just gonna pick it apart, okay? So if we're looking at this graph, what is the domain of g of x?
-4 and 2.
So remember, domain is the range of x values. Where does our graph start?
Negative
Is
infinity.
it -6? And
Yeah, it goes all the way to negative infinity, right? So it keeps going this way and that way. So negative infinity. Okay. Does the graph stop at any point?
no.
Positive infinity.
What about this line right
It'll
here?
stop at the red dotted line.
Yeah, this is an asymptote, right? Notice if you look at this line, it's gonna get really, really close to it, but it's never gonna cross it. So that negative infinity goes to 4. We said it never crosses it, so does it include it?
No.
No, it doesn't. So parenthesis. Now, does the graph pick back up again?
Yes.
Yes.
Yeah. Picks up on the other side of that asymptote, right? And again, really, really close to it, but never touches it. So we're picking right back up at 4. And where's it go off into?
Infinity.
You got it.
If we're typing U in on the computer, like, do we just type in U, or is there like a button on it? Oh yeah, never mind. I see it.
There is a button, but I think you can also do capital U. So, yeah. Great question. All right. So negative infinity to 4. None of the 4s are included because of that asymptote. And 4 to infinity. What is the range? So domain was left to right. Our range is up to down, or down to up, I should say. Where's it start?
Negative infinity.
Yeah, definitely. Where's it end?
Get back here. Guessing 6 again.
So,
negative 10.
So it's gonna be positive infinity.
yeah. So I heard some interesting answers. But it goes up to positive infinity. In this case, this asymptote doesn't matter because we're talking about y values, right? So this graph starts all the way at negative infinity. And if you notice up here, this goes up and it just keeps going. So it's going to hit every y value. Now let me go ahead and clean up the graph a little bit because all right. So what are the x-intercepts?
-2, 2, and 4.
What is it in order?
Oh wait, never mind. I was looking at mine. -4, 0, and 2.
0 and 2. What's important to note about x-intercepts. I think
They're
someone said
ordered
it.
pairs.
Yeah, they're ordered pairs. So this is actually -4, comma 0, comma 0, 0, comma 2, comma 0. And remember, that's if they ask for the x-intercepts. What are the zeros?
-4 and 2.
-4, 2. There's one more, right? What is it?
0.
Yeah. So the zeros are just the x values of the x-intercepts. Any questions on this one so far? Okay. Now, if it wants you to find g of 5, let's go to what are we plugging in for our x? Or what are we looking at? What x value are we looking at?
5.
Yeah, we're looking at 5. So if we go to 5, we find where the graph hits 5. That's right here. And since we want to know what g of 5 is, we want to know what the y value is. The y value is what?
-4.
You got it. Okay. Let's do the same thing for -1. What's g of -1?
-3.
Yeah. Starting at the x value -1, find where the graph goes. The graph goes here, and that is -3.
So those are always off the x.
Yes, as long as the number's in here. Oops, in here, right?
Okay, and then you just go down or like up to see where it hits.
Exactly. If I said g of x equals 5, what value are we looking at? The x being 5 or the y being 5?
Y.
Yeah. So in that case, we'd come up to here to 5, right? And we'd say, oh, it hits it right here. So what is x?
-5.
Yeah. So in this case, you're looking for the y value. In this case, you're looking for the x value.
For letters C and D, if C didn't ask you to give the answers and coordinates, would it be the same, like the same answers? Like, are they the same thing?
It would, so because it specifically says x-intercepts, it's looking for coordinates. So that thing that says IE is ordered pairs, that's just a friendly reminder for you that x-intercept means coordinates or ordered pairs. Yeah, x-intercept is ordered pairs. Zeros is the x values of the ordered pairs.
Oh, okay, thank you.
No problem. So yeah, it's a little weird because you're looking at the same numbers, right? The -4, the 0, and the 2, but one of them is that they're specific. Oh, I can't do that because well, that's okay. So is g of 3 positive, negative, or 0?
Negative.
Yeah. If we go to g of 3, that's here. It's this. That's a negative number. Sorry, this is going to get a little funky because I got to scroll down to the rest of the questions. So this is negative.
Say if it was 2. Like if G was 2, then what would you do?
Okay. So is everyone okay with me clearing what I already have on here?
Yeah, I mean.
Let me, there we go. So let's look at G of 2. So if G is 2, you're saying this, right? G of 2?
Yes.
Okay, so if we go to 2, it's already right here. What is it?
So would you just say 0?
Mhm.
Okay.
Yeah, remember that is one of our zeros, right? Where when you plug in that X, you get a 0. Right here.
Okay.
All right, I have to clear that. So let me go ahead and scroll down a bit. So this wants to know how many times does the line y equals 2 intersect y of equals g of x? What does y equals 2 look like?
A horizontal line on 2.
Yeah, horizontal line on 2. So I'm gonna do that. How many times does it cross?
Twice.
Yeah, right here and right here. So on the question, whoops. It's just going to be 2 times. And here's the irony. We already answered this one, right? G of x equals, for what x value does g of x equal 5, right? We went to 5 because that's y, went over this point, and it's -5. Now, the reason why it says something like separate multiple answers with commas is needed. You might actually get something like, for what values of x does g of x equal -3? Okay. And in that case, you're going to look at the line -3. How many times does it cross? Right here, right here, right here, and right here. And those are all x values. So you'd have to list all of them.
Do you want to put the u after the first 3, or just list them all?
You'd list every single point, the x value. So you'd have x equals.
Is it
Let's see.
points or ordered pairs?
Well, so again, we're talking about x values. It says for what x value does g of x equal -3? So you're actually looking at the point, you're giving the x value. So that would be -3. Looking at this point, that would be -1. Looking at this one, I'm going to guesstimate that one as a 2.75. And then this one at 5.25. It'll give you one with nicer numbers. It would, in fact, it would probably do a g of x equals -4. So if you came over here, it hits there and there. Right? So in this case, what x values? For g of x
3 and
equals
5.
-4. Yeah, 3 and 5. And you separate them by commas. I know, guys, this one's a doozy. Okay, now we're looking at intervals of x such that g of x, our graph, is greater than 0. Once intervals of x. So, and I'm gonna actually write this up here because it's gonna ask for the other one too. So it's intervals of x such that g of x is greater than 0. Let me double check and make sure it's not equal to. Yeah, it's just greater than. And then the other one asks for g of x is less than 0. So what I like to do here to kind of help me see it is I do like a line on the x-axis, so that's where it's 0, right? If it crosses that x-axis, it's 0. And if we're looking for the graph being greater than 0, I cover up everything below that blue line. So following the graph above that blue line, where does it start?
Negative infinity.
Yeah, it starts at negative infinity. Where does it stop?
-2.
Ooh, careful. What's that? This x value?
Oh,
Right?
I'm -4. I keep on looking at like my review and then yours.
No, you're good. You're good. I mean, if you're recognizing it for yours, that's awesome. And this isn't included because we don't want it to equal 0. We want it to be greater than. Okay, where does it pick back up again?
0.
Yeah, it picks back up at 0. And where does it go to?
2.
Yeah. Does it pick back up again at all after that?
No.
No. So that's it. That's the intervals of g of x that are greater than 0.
I have a question.
I have an answer.
Are we talking about the 2 on the y-axis or the 2 on the x-axis?
That's fair because we are kind of going through 2 2s, right?
Yeah.
Remember, we're dealing with x values. The key here is its intervals of x. So we're looking at these values right here. So it starts from negative infinity, catches up to -4. Then it goes below 0, which we don't care about for this part, picks back up at 0, and comes back down at 2. So it's this one.
Okay, great. Thank you.
Now let's take a look at intervals of x such that g of x is less than 0. Where's that start? Where does it start below the blue line, going from left to right?
-4.
Yeah, it starts at -4. Right? This is all below 0. This is below 0. And where does it stop?
2.
Ooh, careful. What's this point right here? No,
Oh,
it's
origin.
yeah, the origin. So 0. Does it pick back up below 0?
No.
No?
Yeah, it
So-
starts at 2.
Yeah, it
Picks back up at 2.
picks back up at 2 and keeps
Oh,
going.
that's what I meant to say earlier from 2.
There you go. We're tracking. Where's it end here?
Infinity.
Does it cross this line though?
It ends at 4.
Yeah. I mean, yeah, I guess.
Yeah, it ends at 4. Remember, this is that asymptote. It gets
Oh, okay.
really close to it, but it doesn't touch it. So it ends at 4. But that it also picks up down here, right? And where's it pick back up?
Around like 4.5.
Well, it looks like that, but remember, this is going to keep going and that's going to keep going. So it's going to get really close to 4, but not touch it.
So will we bracket that off?
We don't bracket it because it's not included. It'll get really super close, but it won't actually touch it. So it doesn't include 4. It's kind of like a little hole, kind of flips over. And this is still below 0, right? Below that blue line. And where's this go off to?
Infinity.
Yeah. And close that off. So that is the intervals of everything on this graph that is less than 0. The thing that you're definitely going to want to remember is this asymptote right here. Did someone have a question? Okay. So just remember, if you see an asymptote, it's going to reach that point, not include it, and pick back up on the other side of it. Any other questions about this particular question? I know it's got a lot of parts involved to it. Okay, let's go ahead and move on. We did plugging in previously, but let's go ahead and do a quick differential. It's raining over here. Let's do a quick one of these. So if we have f of x is equal to negative 4x squared plus 3x minus 7, what's f of x plus h? And again, remember, whatever we're plugging in for x, we put in parentheses. Since we're plugging in x plus h, we will put that x plus h in the parentheses. Are we done here?
You'll need to distribute.
Yeah, we definitely need to distribute, right? We could distribute this, but what about this right here?
How would you factor it?
Gotta foil it.
Yeah, we FOIL it, because remember, this is the same thing as saying that this is x plus h times x plus h. Okay. And for the sake of time, that'll be x squared plus 2xh plus h squared. When you're foiling it, you might end up with like x squared plus xh plus hx plus h squared. These are the same. So just remember that these two are the same. So that's the same thing as 2xh. Those x and h are interchangeable because they're multiplied. Bring everything down.
Why?
Yeah.
Like, say you have your first like f x plus h. Like, why? Like, when the x comes, I'm kind of confused.
Okay. Yeah, let's go ahead and do this part real quick. Okay, so if we do this, x times x is what?
X squared.
X squared. Okay, so that's the first. Now let's do the outer, x times h. X times h is just x h, right? Or x times h. Now we do inner, we have h times x. It's the same thing, right? hx or xh. And then last, h times h, h squared. Just remember, this is the same thing as this. What's 1 plus 1?
2.
Yeah, so we're left with 2xh. You can bring this part down. Did that help?
I'm just having like trouble like at the very beginning step, like how you're plugging that equation in.
How we're plugging x plus
Like-
h into this?
Nah, how you're plugging the negative 4x 2 into the fx plus h.
Okay. So this is the original equation, right? We were
Mhm.
given this. We want to
Yeah,
find f
I
of
just don't know
x.
why you don't have the 4 in the parentheses.
Well, because we're only plugging in for the x.
Oh, okay.
So the -4 has got to stay there. And then because this is squared, we have to FOIL this out before we can take care of that -4. That -4 comes back. It doesn't go away.
Oh, I think I'm looking at this like reverse. I think I'm trying to plug in like the -4x for like the fxh, not the x plus h to the -4. If you know what I'm saying?
Yeah. Yeah. So just remember when you're plugging it in, when you're plugging something in for x, that's going to go in parentheses. If there's a number like this -4 up front, whatever squared has to be taken care of first because it's an exponent. Then you can multiply that -4. So in this case, 3 times x is 3x. 3 times h is 3h. And the negative sign comes down. What's our last step here?
What was
Remember
your
this.
question?
What's our last step?
Distribute the 4.
Yeah, we got to distribute that -4 to everything. So -4 times x squared, -4x squared. What's -4 times 2?
-8.
Yeah, so -8xh. -4 times h squared is -4h squared. Bring everything else down. And I know you want to combine stuff, but there's nothing to combine here. We have no terms in common. We have an x squared, an xh, an h squared, an x, and an h. So this is really common as your answer when you're dealing with an x plus h. Okay.
Would you get this wrong if you don't put it in descending order?
That's a good question. I don't know if you'd necessarily get it wrong, but we like to put things in descending order. It's a lot easier when solving equations and dealing with graphs and all sorts of stuff like that. So if you can put it in descending order, this order right here could be considered descending order. Usually if you're plugging it in like this and you're just following it down, it ends up in this order as it is. I'm going to just go ahead and erase this bit right here. Okay. All right. The last bit of this is we're doing f of x plus h minus f of x all over h. This is a lot. So we have our f of x plus h, which is -4x squared minus 8xh minus 4h squared plus 3x plus 3h minus 7. Okay. And what we're subtracting is our f of x, which was given to us, right? Remember when you're doing this part to put this in parentheses because you're subtracting this whole thing. So this is -4x squared plus 3x minus 7. And all of this is over h. Having set it up, what's our first step from here?
Should distribute the negative and combine the like terms.
Yeah, distribute the negative, combine like terms. And these should be pretty smooth after you distribute this negative when it comes to combining. So you have -4x squared. This first part stays the same, right? xh. Of course, it's good if you make sure you copy it down right. Minus 4h squared plus 3x plus 3h minus 7. Yes, for those that attend, put your full name in the chat. You will get a recording of this if you have to leave early. So negative times negative is a positive. So we have positive 4x squared. Negative times positive is a negative 3x. Negative times negative is a positive 7. Again, this is all over h. Yes, it will be emailed to you to your TCC email. Here's where things should kind of start to turn out nicely. Whenever you're dealing with these, you should always be able to, in a sense, cancel out some stuff here. So what can we cancel out when combining like terms? Someone asked, how do I go back and put my full name? Just type your full name in the chat box, Zoom chat box. So what can we combine or get rid of?
Your x squared.
Yeah, we have negative 4x plus 4x, right? That's 0. Okay, what else?
See your regular x.
Yep, positive 3x minus 3x. Anything else? Should be one more.
And then the sevens.
Yep, negative 7 plus 7. Okay. Cleaning this up, we have negative 8xh minus 4h squared plus 3h all over h. What can we do next?
Divide by 8.
Take out an 8.
Yep. Pulling out an h, we're left with negative 8x minus 4, only one h left, right? Plus 3 all over h. Now what can we do with those h's now that you've done that?
Divide.
Well, what's h over h?
It's 1.
Yeah, because it's 1, we can cancel it out. And what we're left with is a lot simpler than what we started with. Negative 8x minus 4h plus 3.
Why couldn't you just divide the h before you factor out the h?
You can, as long as there's an h in every term. So if you see that and you're comfortable with doing that, you're more than welcome to. If you get to, if you get to this step and you're like, oh, there's an h in every term, I'm going to take out an h, take out an h, take out an h, and cancel with that. Yeah, you can absolutely do that. Doing this step tends to help us stop from making mistakes, like maybe taking out too many h's here. Or maybe there's not an h in every term, so you can't do that.
So the fx plus h, that like long equation right there would be our answer for the first one?
Yes, yeah, this right up here is going to be that negative 4x squared minus 8xh minus 4h squared plus 3x plus 3h minus 7. And then our answer for the final one is just going to be negative 8x minus 4h plus 3.
Okay, and then so like for the fraction, when we have x again, we just put that second, we get put that second one up for minus fx, like, so it'd be like, we'd have that long equation, and then we do minus negative 4x squared plus 3x minus 7, put that in there.
Are you talking about this part?
Yes.
Yeah, just remember when you're subtracting something, you're subtracting that whole thing. So
like
that's why.
Signs.
So what?
Flip the signs is what you're basically saying, or about to say?
Yeah, that's what you end up doing. When you distribute that negative, you flip the signs. Absolutely.
Okay, and I see you have like right below that, I see you have like all these slashes going through these numbers? Like after we like, why did you do that?
Okay, you must have missed this part. So we combined like terms. And we had a negative 4x squared plus 4x squared, which is 0. A positive 3x minus 3x, which is 0. Yep, and a negative 7 plus 7, which is 0. And these types of equations, you should always be able to cancel out those last 3 terms.
Okay.
So look out for that. And if something happens and you notice you're not able to cancel something out, maybe take a couple steps back and see what wrong turn you might have taken. Any other questions about this one? I know this one is a doozy. Okay. Sorry about that, guys. We got a little bit out of order. We did that one. I'm going to find I want to find a circle one. Actually, let's do this one really quick. If we want to find all real solutions to this equation, what's the first thing we need to do?
Put all the R's on the same side.
Yeah, well, and in this case, maybe because we have a cubed, I would put everything on one side.
The exponent.
So 7r to the 3rd power plus 8r to the 2nd equals 20r plus 32. Let's go ahead and move everything over to one side. So we are subtracting 20r and subtracting 32, which of course we do to one side, we do to the other. 7r cubed plus 8r squared minus 28r minus 32 equals 0. Now we have 4 terms here. What is a thing that we can do to break this down?
You can separate them.
Yeah, you're definitely on our track. We're going to factor by grouping. So we're going to separate them by factoring by grouping. Okay. So what we're going to do is we're going to factor everything out of the first one and then factor everything we can out of the second bit. Okay. What can we factor out of the first one?
R. Well, R squared.
Definitely R squared. Absolutely. Good job. So we're left with 7r plus 8. Okay. Now, what's going to be important here is whatever we factor out of the second one, we need our inside to match this one. Okay. What can we factor out of the second one?
4.
4. Positive 4 or negative 4?
-4.
Yeah, I heard someone say negative 4. Good job. So if we pull out a negative 4, that negative 28 becomes a positive what? What's negative 28 divided by negative 4?
7.
It's gonna be 7.
Yep. And negative 32 divided by negative 4?
Positive 8.
Yep. Notice we have exactly what we had in the first one and second one. What we're going for. So looking at these and knowing that that's multiplied by that and that's multiplied by that, what do these two terms have in common?
R squared minus 4 in the first set of parentheses, and then 7r plus 8.
In the second, yes. We pull out that 7r plus 8 because that's what they have in common. And you're left with r squared minus 4. Good job. Okay, now going back, we're looking for real solutions. So we've got to solve for r, right? So we're going to set each of these equal to 0. 7r plus 8 equals 0, and r squared minus 4 equals 0. For the 7r plus 8 equals 0, what does r equal?
-8, 7.
Yep, r equals -8/7. That was done by subtracting 8 from both sides and then dividing by 7. Good job. How do we solve for the r squared minus 4?
You'll add 4 to both sides and then square it.
Yeah, good job. So we have r squared equals 4. We're going to take the square root of r squared, and we're going to take the square root of 4. What happens when we take the square root of something? How many answers do we get?
2.
Yeah.
Negative
Yep. And what's the square root of 4?
2.
Yep. So our answers, and the way you would type it in here would be negative 8 over 7, comma 2, comma negative 2.
I'm kind of lost after you got after we've like got the matching pairs of 7r plus 8.
Right here?
Yes, ma'am.
No problem. So this r squared is multiplied by 7r plus 8, and this negative 4 is multiplied by 7r plus 8. So what do these two have in common?
They got the same.
Yeah, they have that same
pairs.
factor.
Sure.
Yeah. So if we factor that 7r plus 8 out, what's left?
Oh, I got the r squared minus 8 or minus 4.
Mm-hmm. Yeah. And then we set each of those equal to 0 and solve.
All right.
Okay, I'm going to find one circle equation, a good one. Let's see, whoops. I think that was a good one. All right, so let's go ahead and do this one, and then we'll wrap it up, okay? So we want to determine the following for the circle whose equation is x squared minus 2x plus y squared minus 12y plus 36 equals 0, okay? So if we are going to find the equation of the circle, what are we going to be doing here? What have we got to do to find the equation of the circle in standard form? Anyone know what standard form is?
Like the formula?
Mm-hmm.
You have to find h, k, and r.
Yep, we sure do. So we've got to do x. This is the form we're putting it in, right? X minus h quantity squared plus y minus k quantity squared equals r squared. Okay, that is our standard circle formula. Okay, so we're going to take this and turn it into that. So to do that, we've got to complete the square. So what I'm going to do is I'm going to put my x's together, x squared minus 2x, and then I'm going to leave a space, and then I'm going to do my y's, y squared minus 12y. I'm going to leave a space, and then we have plus 36 here. What do we need to do if we're going to try and complete the square?
Put it on the other side.
Yeah, we need to put it on the other side. So I'm just going to go ahead and set this equal to negative 36. And we did that just by subtracting 36 from both sides. Okay. So how do we find the value here that will make this x portion a perfect square? What do we do?
You'll divide the base of negative 2x by 2 and then square it.
You got it. Yeah, we take this letter, right? B divided by 2 and square it. So negative 2 divided by 2 is what?
Negative 1.
Negative 1. And what's negative 1 squared?
1.
1. So we're going to add 1. And if we add 1 to this side, we add 1 to that side. Okay. Let's do the same thing for y. If our b is negative 12, It's negative 12 divided by 2 squared, right? So what's negative 12 divided by 2?
-6.
Negative 6. What's negative 6 squared?
36.
36. So we got to add 36 here. And if we add 36 to that side, we add 36 to this side. Okay. Now, x squared minus 2x plus 1. How do we write that in the x minus h parentheses squared form? What is that perfect square? How do we factor that?
You do the same formula for x that you do for y, right?
Yeah.
Like, okay.
Yeah, absolutely. We use the same formula because we're doing the same thing, just with the different variables. So what is x squared minus 2x plus 1 factored?
What is it? Just one or x plus 1, then x minus 1. Or,
Okay, so we
yeah,
got
no.
the ones. Careful though. Right, 1 times 1 is 1.
Minus.
Yeah, minus. They're the same, right? That's what we're going for, a perfect square. So another way to write this, x minus 1 times x minus 1 is x minus 1 squared. Okay. Now let's look at the y. We have y squared minus 12y plus 36. What's that factoring to? What times what is 36?
6. No?
Yeah, 6. Now, are they going to be positive or negative? If we went
Both negative.
both negative. Okay. And again, the way that we write that, y minus 6 times y minus 6 is the same thing as y minus 6 squared.
Oh,
okay.
At like the very top of the equation when we have equals negative 36, why do we put the plus 1 and then negative 36 over there too? Or the plus 1 plus 36?
Remember how we added 1 and then we added 36? Whatever we add to one side, we have to add to the other. So whatever you add here to make that perfect square, we got to add to the other side so that the equation stays the same. And what is negative 36 plus 1 plus 36?
1.
Yeah, it's just 1 because those will cancel, right? Okay, we have this in our circle form. So we have the first part, we have our equation, right? We have x minus 1 squared plus y minus 6 squared equals 1. What is the center of our circle? Our HK?
-1 and -6.
Careful, let's look at our formula again. These are already negative, right?
A +1 and a +6.
Yeah, you got to be careful about that. If you end up with an x plus 1, then it's a -1. But if it's a x minus something and a y minus something, it's just that number. Okay. What's our radius? Or our r?
One.
Yeah, because our r squared is equal to 1, but that just means that our r is equal to 1 because the square root of 1 is 1.
So when you have h and k, you just get rid of it, or you just flip the signs.
Yeah. Yeah. Okay. And then the graph. Go ahead.
My bad. Could it ever, like, say if it was +1, +6, would you still flip the signs, or just can it not be negative?
Good question. So if you had, and I'm going to put this in a different color. If you had x plus 1 squared plus y plus 6 squared. Compare this to the original. The original is x minus h, right? So this h is actually equal to -1, and this k is equal to -6.
Okay, so you just go off the original?
Mm-hmm. Yeah.
Oh,
right.
the original equation. Okay.
Yeah, the original equation. Thank you for clarifying that. Original equation. And then if we're graphing this, we're going to start at our center. So we're going to go to 1, 6. And then our radius is 1. So you can go 1 in any direction. And we have our circle. It's super tiny, but it works. That's it. And I know this one had a lot of work involved. Any questions on that? Okay. I'm going to have to end the test review here. I will send the recorded copy to you guys, but thank you for coming. Does anyone have any other questions? And of course, be sure you do any test reviews that you might have for your classes.
Yeah, I had a question over it was one of the questions. It was just an equation and it says give 3 solutions to the equation.
Oh yeah, okay. We did one of those earlier. Let me pop through it. Like this?
Yes.
So if you're looking for solutions and they have to be ordered pairs, what are those ordered pairs? What values are those?
We have 2 and 5.
Well, that's the equation. But what are our ordered pairs? What's the first value that's in here usually?
Oh, X.
Yeah. So we're looking for X and Y's, right?
Mm-hmm.
So you could plug in any number for X and any number for Y and solve for the other one.
Okay.
So for instance, you could say X is equal to 0. Plug in 0 for X and solve for Y. And in this case, that would be 0 and you'd end up with Y equals 4/5. So what would your order pair be then?
Would it be
0, comma,
and 4/5?
Yeah. Exactly. Likewise, you could plug in 0 for Y and solve for that, or even plug in a 1 for X or a 1 for Y. That one's really open to you. It's just a matter of picking any value, plugging it in, solving for the other, and making sure the answer you write down is the ordered pair.
And for this question, you could just do like, say, if you wanted to do X for all of them, you could just do 0, 1, 2. All right.
Yeah, absolutely.
Oh, okay.
Yep.
All right, thank you.
No problem. Okay. Good luck on your guys' tests. And just remember, if you need some extra assistance, you can always come to the Learning Commons for some tutoring. Okay.
And what time, like, are y'all, like, when are the Learning Commons open?
Good question. So we're open until 7:30 p.m. 7:30 a.m. to 7:30 p.m. Monday through Thursday, and Friday 7:30 a.m. to 5 p.m.
Do you tutor there, or is it just like random tutors?
No, I tutor there as well.
You have to like set up. You have to set up an appointment, or is it just
no?
like...
It's drop in. It's drop in.
Okay. All right. Thank you so much.
No problem. You guys all have a great night. Try not to get too wet because it's pouring outside.
I have to work in this.
So sorry.
Yeah. Yeah, go on.
Have a good one.